So not many updates to last time.
Okay.
I did try copying over the library folders and recopying all that, reloading everything. And that took away the module issue I was having with the display screen.
Okay.
But I think it's like stuck in a loop when I run it through Mu.
Huh.
Um, it it'll say like initialized, and then nothing will change, and then nothing will change on the screen, nothing will change on the code, and then I'll like control C like stop and reload it, and then it's like this
Okay.
process
Can
was
can you
stopped.
show me
Oh
that?
yes,
Can
I
you
can show
mute
you
on the
that.
screen?
Yes. Yes, I can.
So one possibility is you have a different test code on there that isn't doing anything with the display.
I hope not.
I hope it is because it's really easy to fix.
That's true. That's true. In terms of embarrassing, that would probably be up there.
Oh
Okay, let's see
yeah.
this one.
Everybody makes mistakes all the time.
All right, can you? Oh, you can't see my screen. Right.
Ah,
You
now I can
see Mu?
see mu. Yes.
Okay. And then if I open, do you see like the Circuit Pi
Yeah. And you're going to
folder?
open
Okay, perfect.
code.py.
Yep. So I'll load. No, already there. Code.py. This looks like the display one.
Okay.
And then serial.
Yeah.
And then reload the code. And it just says initialize display and then nothing change. Oh,
Oh, well, if you look through the code, so let's do that. Let's go to the top of the code.
okay.
Um, so we have a little section there where we import a bunch of stuff. Those are
Right.
libraries, right?
Right.
And when you were getting a module error, because it would say module not found, and it was because one
Yeah.
of those libraries it didn't have. Um,
Gotcha.
and time and board and display IO and terminal IO and four wire are all built-in libraries.
Oh,
Um,
okay, okay.
so it was one of the other two that you hadn't put in the folder where it was looking. Um,
Gotcha.
okay, so then the next line, line 9, is um, if somebody has been using the display and is hogging the display bus, let it go. Um,
Okay.
because if two users try to use the same SPI channel, things will go badly. Um,
Yeah.
so then it's make the SPI bus, and then it's assign a couple of pins. Um, and so you can see that the CS pin, the chip select pin, is on D12, and the data command pin is on D11. And
Mhm.
if we got those wrong, either because they're wrong in the code or because you got the wiring wrong, we can play around with those. But they ultimately they need to be the same as what's in the main Stella code.
Yeah. What did anything should the wires have been plugged into there?
Should the
Or
wires have
is
been
the
plugged into
like
where?
should I have had wires in D11 and D12?
Okay, so we have a coordinate system issue. Um,
Yeah.
D11 and D12 are the digital pins on the microcontroller. They're not
Right, not the
row,
physical.
they're not
Okay.
row D column 11. Yeah, isn't
Gotcha.
that irritating?
Okay. Yes. Yes. So I was staring at this when it wasn't working the first time. I'm like, there's nothing plugged in there. It should work. I
Right.
think maybe. Okay.
So there's
Oh, that's
a
annoying.
um so there is a pinout for the feather. Um
Mhm.
so let's switch share for a second and I will show you.
Okay.
Um so it is feather and it's a ESP32S3 pinout. Okay. Um so let me share this. Okay, so what we're looking at is the ESP32S3 page on Adafruit. And if you've never seen this before, you should get used to it.
Okay.
Um, and if you look on the silk screen, which is the white print, um, on the board, you'll see these numbers where it says 13, 12, 11, 10, 9, 6, 5.
Oh, yeah, yeah, yeah.
Okay. Those
Yep.
are the digital pins. So we're
Gotcha.
using D11 and D12. So that's between 13 and 10 there.
Gotcha.
Those are the two pins that those are two command pins essentially to the display. The display also needs to know about S clock, MOSI, and MISO, which are on the other side of the board down here.
Yeah.
So one of the things that you can do with the power off is you can use your meter to check continuity. Um, so on the display board itself, the display pinout board, um, let's see. So that would be, where would that be? That would be Adafruit, and that'll be the I Spy board. Okay, so if we go and look at this thing, right, this should look familiar.
Yeah.
So
That's
if
the
you put your one end of your meter on MISO and then go over to the microcontroller and look at the Mi pin, that should those should be in contact with each other electrically.
Or not.
Oh, all right. Well, that'll do
Wait,
it.
wait, hang on. Let me close. So let me take the screen off so it's not like flailing around. Sorry, I'm trying to like absorb and look at the same time.
Yeah, yeah.
So the miso on the the screen should be by wait, hold on. I'm so confused. All
There's
the
a
wires
lot of
are like
stuff going
intertangled.
on. So
Yeah.
slow down
Yeah.
and look and take your time and ask me what you need to ask.
Okay. So miso on the display chip.
Hmm.
Which one is that supposed to be
It's
electrically
supposed to
collect?
go to MI. So
Okay.
MISO goes to MISO in this
Oh, okay.
arrangement. It's not MOSI to MISO, right? It's main in,
Gotcha.
serial out. And that's the same at both ends.
Here.
Have
Yeah,
you
I definitely did not do that. I swear I double checked the
have you put the SD card on yet?
yes.
And did you pass the test code for the SD card?
I've not done that one yet. Can you
Ah,
try it right
okay.
now?
No, don't bother.
Okay.
So the SD card and the display share MOSI, MISO, and S clock.
Oh,
So if MOSI, MISO, and S clock are not connected properly to the display, the SD card is probably also not going to work.
oh, they are connected.
That's kind of what I thought you would find
Yeah, I
based
just
on
had
your.
I have the button in the way. I could not, yeah, okay.
Oh,
I just had
yeah,
the
yeah,
button in
yeah.
the way. And also I flipped it instead of like, yeah, so
Oh,
I was
yeah,
just
yeah.
getting myself disoriented for no reason.
Sure.
Okay.
Are you familiar with this diagram? that we're seeing on the screen now?
I've seen it before, but
Well,
I
that's a
wouldn't say I'm
start.
familiar with it.
Okay. So this is a schematic diagram, and I've written this specifically for people who don't know how to read one. It's kind of like physical reality, which is not typical for schematics. So if you look
Gotcha.
at the display connector, right, the breakout for the display, and you look at, let's say, MISO, because we were doing that before, right? And you trace along that line down here, and you can see that it says over here SPI MISO blue, right? And then you can follow that over here, and that should go to the MISO pin,
Right.
right? So the idea here is this is the electron's view of the board. Um,
Oh, because each row is connected. Electro. Oh, because of the little like bridging in between. I was like, that doesn't
right.
connect,
So
but it does connect.
yeah, let's call them columns
Okay.
there because
Okay,
otherwise the
columns.
rows would be confusing. Um,
Okay. Oh yeah.
so
Sorry.
yeah, so like column 29. If you
Yeah.
connect to A, B, C, or D in column 29, that'll connect to E on the display breakout board.
Right. That makes sense.
And if you were doing this on a custom printed circuit board, those connections would be buried inside the board and you wouldn't be able to see them.
Oh, okay.
And so that would be even more confusing. So then you really have to
Yeah.
just poke it with a meter and try to shove some electrons through and see where they go.
Yeah. I think everything's connected. Maybe.
Well, it's one thing to see if to sort of look and see if they're
Oh,
connected.
use the,
It's
yes,
another
use
thing to
the
poke them with the
multimeter.
meter and see if the electrons think
Okay,
they're
hang on.
connected, because that's what counts.
Yeah. It's so hard to orient with all all the wires.
Yeah.
Like, where am I? Okay,
Well, so
so,
that's why you go right to the pin on the board, right? So you
oh,
look at the
okay.
pin at the MISO labeled pin on the display board, and you look at the MISO labeled pin on the processor and poke them with the meter and see if they're electrically connected. Because then you don't have to worry about all the rest of the detail.
Yeah. So, and Miso. Yep.
Good.
Hmm. The beat means they're connected, right?
Yeah, the beep means they're connected.
Okay, yeah. Okay, yeah.
And well, you don't have to believe me. You can take the two probes and touch them to each other and see if they beep,
Oh, yeah. Oh, yeah.
right? And in
Okay, yeah.
fact, whenever you're doing this, you should always take the two probes first and touch them to each other. Because if it doesn't beep, you can spend a lot of time poking at things and
That
not
means
like you
nothing.
have the meter set wrong or the meter isn't working or one of your leads is unplugged or whatever. Um,
Yeah.
so always check your equipment.
Okay, gotcha. Write that down.
It takes just a second and it can save you hours of head scratching.
Yeah. So now what?
Well, so did you do all the other ones?
So miso to miso, mossy to mossy, and
Yep.
then
S clock
which
to
one
S
does
clock.
S clock to S clock? Is that CL S clock or SCC or
SC
SCK?
SCK. Yeah,
Okay,
it should be yellow. I chose yellow for that.
okay, okay. Those are connected.
Good.
Okay, and then mossy to mossy, and those are connected. Okay.
Okay. So you already know that power and ground are connected because when you turn the unit on, the display glows,
Yeah.
right? So you could poke those if you wanted to, but they, you know that they're working.
Yeah.
So then the other two lines that you need to operate the display are the D10 and D11 lines. And one of those goes to DC and the other one goes to CS.
And that one is in the code. So CS goes to D11 goes to DC, and D12 goes to CS. Okay. Is it the CDCS one?
Yeah. What
Okay.
about it?
Just that's the one I'm checking.
Oh, okay.
Hmm. These aren't connected. All right, so there's the issue.
All right. So there's one other thing that you should check
Mhm,
while we're here with the meter, um, which is so think about S clock and MOSI and MISO for a second.
mhm,
We went to all the trouble to run three separate lines for those things.
mhm.
So you want to make sure that they're not accidentally touching each other, that they're not shorted. So how would you
Okay,
check that?
with the multimeter and seeing
Yeah,
if they're zero.
right. So if you check one to the other and they're connected to each other, they shouldn't be.
Oh, grab the standard real quick. Hang on. Not twirling on my computer. Okay. Nope. None of them are connected.
Okay. So this procedure that you've just gone through is called continuity check or buzzing out is the term that we use in the industry because the old meters didn't beep, they buzzed. Um, okay. Um, and for buzzing out, what you do is you check that there's continuity between things that should be connected and that there's no
Mhm.
continuity between things that shouldn't be connected. So it's
Yeah,
not just enough to see that they're connected. You also have to make sure that they're not connected where they're not supposed to be. So are they connected where they're
yeah,
supposed to be? Are they not connected where they're not supposed to be? And that's buzzing out.
yeah. No wonder
And
Mike checks the connection so much
what's
during the
that?
process. No wonder Mike checks it like checks the
Right.
connection
Yep.
so much during the process and not all at the end.
Okay, so what have we found so far?
Okay, just double check this one super duper quick. And I just check the CS one.
Uh-huh.
Okay, hold on. I'm just having like a hell of a time orienting myself. Give me like 2 seconds.
Yeah, yeah, yeah. Take your time.
Okay, so they are connected. I was just in the
Aha.
wrong spot. So everything that's supposed to be connected is connected,
And
and everything that is not supposed to be connected is not connected.
aha. Okay. All right.
Why isn't it working?
So right. So we did the obvious thing, right?
Yeah,
And definitely check the obvious things first, because
yeah,
otherwise you can, go round and round and round and round for hours and hours, and then you're like, oh, I didn't check that this was connected to, oh, okay. Um, so, um, all right. Well, that's interesting. Um, hmm. Now I don't know. Um, because and you're sure that the CS goes to the right pin and the DC goes to the correct pin. Also, they're not swapped.
let me double check.
Yeah.
The CS one is just one that says PCS, right?
Yeah, TCS T is for
Okay.
the display. It's the thin film transistor is the name of the display.
And
TCS
then
and TDC.
and the code says CS to D12, and then B11 to DC. Okay, so let me double check those are correct.
Okay.
DCS 12, and that's D11. What's like the correct way to do this? Like I feel like I keep
This is
flipping
the
the
correct
board
way to
back
do
and forth.
this.
Okay, okay. Exactly. I just
This
keep like
is
flipping the board back and forth.
exactly
I
the
wasn't
correct way
sure.
to do this.
Okay. Okay. Fair enough. That's what I needed to hear. You know, MISO. Mm. All right. Yeah. No, those are correct.
Okay.
Correct.
So the next thing that you would do, if you had another one of these that was already working, you would go
Hmm.
see if that was working with that code. You don't have another
Yeah.
one that's working, so I am right now running the test code on mine.
Okay.
Okay, and that's what the code should look like.
Yeah. Hmm.
All right. Um, so one of the other things to try um, is anybody grounded that shouldn't be grounded? And is anybody connected to power that shouldn't be connected to power?
Probably.
Well, I mean, we hope so
No, I know.
because,
No.
because then it's easy to fix. It's hard to fix
Yeah.
the things that when you poke them and you can't find anything out.
Yeah.
So connect one end of your meter to ground or power, whichever one you're investigating, um, and then go along and poke all of the relevant wires.
I just need one. Oh, yeah, yeah, yeah. So that's
And while you're at it, you can poke the ground pin on the display out board, and make sure that that's connected to ground. Because maybe it's lighting up because it's using something else as ground. It's those things are complicated enough that they can get into some weird conditions.
so this one's ground, and then the display will say ground. Okay. Oh, that's the microcontroller. Maybe the display. I guess not. Oh, no, there it goes.
Yeah, good for you for double checking because you can also misprobe something and spend a lot of time trying to figure out what's going on.
Yeah. All right. Yes, that connected. All right. So then I'll check ground to ECS. What should I be seeing? Just
What should you be seeing where?
on the micrometer or multimeter.
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 There you go. Um, take the two probes and touch them together and see what the meter has to say for itself.
0.
Yeah, so it should be zero.
Okay.
Um, and so what you want is zero where things are supposed to be connected and whatever the other is, OL or something, when they're not connected, when they're not supposed to
Okay.
be connected.
Ground still works.
Good.
So everything on the display chip looks right, or reads not 0 to ground, so that's
All right.
good. Then I'll check these two. This is gonna be like a really the two grounds aren't like should those be connected at all?
Which two grounds?
The, like the ground at the top of the board and the ground at the bottom. So like I think it's a below A and above J.
Oh, you mean on the display breakout board?
Yeah, yeah.
Well, so they should be connected internally
Mhm.
on the board itself. So if you poke them and they don't both and they don't show up as connected, that would be weird.
Uh-oh.
Where are you seeing the other ground?
Like this one and then this one. Ground is
Ew, ew,
positive, right?
ew, ew, ew. Ha 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 ha. You may have built yourself in a little disaster.
Uh-oh.
No, 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 actually, wait. Um, so we are using one half of those for a different purpose altogether. We're using them for the I squared C bus.
Okay.
Um, right? So the ground one is the one that the black wires go to. That's below A.
Yeah.
And then below that is the plus, right? That's the where the 3 volts goes, right?
Mhm.
On the other side of the board above J is I think it's a plus there or a minus, I forget which. But we're using it for SDA. So we have white wires running to that.
Okay.
Okay.
Yeah.
And then we're using the other one further out for uh what is it called? SDA and SCK. No, SCK is the other one. Uh SCL. That's the other one. And that has
Gotcha.
screen wires going to it. So no, they don't need to be connected to each other. In fact,
Okay.
you don't want them connected to each other. Um,
That's what I thought. I wanted to make sure.
so remember
Okay.
the problem that Mike had, where the ground, so there's that whole long ground thing just below A. So
Yeah.
maybe poke it at one end and poke it at the other end and make sure that all of the traces that are on the board are actually connected to each other.
Yeah, those are working.
And then do the same thing with power. Poke the power bus at one end and the power bus at the other end, the 3 volt power bus, and make sure that those are
Oh,
connected.
all four are good.
Okay, so at this point, having buzzed everything, and you think it's all
Mhm.
correct, the thing to do is to make yourself a little list, um, and just write out each connection, who's supposed to be connected to who, and then go back and check each connection and then check to make sure it's not connected to any of the other things, and then check the next connection and make sure it's not connected to any of the other things.
All right.
Okay. Um, Another thing that you could potentially do wrong is to put in the ribbon cable wrong, but because the display was lighting up, it suggests to me that you're doing that correctly.
Yeah. And what's it supposed to look like? It's supposed to have like a red or a blue border with like a red.
Yeah, it's supposed to show up and do display things
Okay.
like
That's what I
words
was afraid
and
of.
squares and, yeah.
Yeah.
The other thing that you could do is you could check your um, jumpers on the back of the display board and make sure that they are electrically connected on the display, not the.
Oh, right. Sorry. Are the jumpers the two little or the two big circles?
Hmm? No,
What are
no,
the
on the display
jumpers?
unit itself, on the piece of glass.
Oh,
Yeah, yeah.
okay, so like
So
the
look on the
IM.
back and make sure that
Yep.
IM0 is not connected. That should
Yes.
be pretty obvious. And then
Yeah.
poke IM1, IM2, and IM3 and make sure that they're connected one side to the other.
Yep, those are all connected.
Okay, good. So one other thing that you can try. since I've given you more than one display,
Always try a different
right?
display.
Maybe that display is bad,
Yeah.
right? So maybe it has a problem with soldering internally or the connector's not working properly or something like that. So you could try a different display.
Dang.
And this is the process of debugging. And this is what it's always like.
Yeah.
It doesn't get any easier. My
Yeah.
head electrical engineer spent 2 days trying to figure out why his circuit wasn't working. And he's been doing this for 20 years now, right? He spent 2 days trying to figure out why his circuit wasn't working. And there was a little teeny fiber of wire connecting two pins inside the connector. And it
Wow.
took him forever to find it. And he is the admiral of the Pacific Fleet obsessive.
Oh, so he's got me beat.
Oh yeah, he earned it.
Wow.
So this is just what it's like.
Okay. As you know what? That makes me feel better. Not much better, but at least a little better. That this isn't like, wow, you really messed it up. Just this is just how it is.
This is just how it is.
Okay.
When the WMAP uh, satellite mission was in the Space Environment Simulator chamber. So this is the biggest vacuum chamber that we have at Goddard. Okay.
Yeah.
And you need a standing army to run it. So there's like 40 people to run it. And so they got in there and everything was working okay, and then it all stopped working. And they spent a week trying to figure out what was going on. And they eventually tracked it down to somebody had installed a bridge over a bunch of cables in a slightly incorrect position so that when people walked on that bridge, two of the wires got compressed enough that they shorted through their insulation.
Oh my God.
Okay.
That's bad.
Yeah. Electrons don't care what you intend. They go
Yeah.
where they go. Um,
Yeah.
so yeah, with everybody being as careful as they possibly could on a satellite that was getting ready to go into space, and still they had that problem. Um,
Yeah. Oh my
so
gosh.
yeah, that's just how it goes.
Yeah. Dang. I don't know if that's supposed to make me feel better or worse, actually. I guess in the
It
moment
just
better,
is.
probably down the line worse.
Yeah,
Yeah.
yeah.
Oh boy. Well, I won't make you sit on the call and watch me write every connection and test every single one.
Well, I mean, we can resume the call after you do that. That's a
Yeah.
possibility.
Yeah.
Right? Or you might run out of time for today and then you do it some other day. But
Yeah.
um,
In all honesty, it probably won't be a today project. It'll probably be later in the week, but
yeah, yeah.
yeah.
There is one other technique that people have
Okay.
used for um, for correcting circuits that are misbehaving, and it worked better
Mhm.
in the olden days um, when the components were much more robust. Um, and nowadays, everything is really super small and pretty sensitive to voltage. But one of the things that you would do if your circuit wasn't working properly and you couldn't figure out was you'd put a high voltage across it and let it fry whatever was in the way where it shouldn't be. Um, so I don't
That's
recommend that.
funny. No, I know it's funny though. I'm gonna write it down.
So that would be known as a high potential debugging, right? High potential just means high voltage.
Yeah.
So they would call it a high pod for high potential. And if you have things that require high voltage, you'll do a high pod test, right?
Yeah.
Because you need to make sure that the high voltage isn't going where it's not supposed to. Um,
Yeah.
so yeah, but
Yeah.
no, we're not going to do
We
that
probably
here.
don't need to do that. I might just as if I changed anything. I might just like double check right now. See if the
Sure.
screen decided to wake up. Yeah.
Yeah, yeah.
Um,
Sometimes electronics are just like that. Um,
yeah.
my former boss, when he was a graduate student, they had they put a picture of the guy who the electronics were scared of inside the electronics cabinet to try to remind the electronics that he was out there. Um,
That's
to
funny.
try to ward off some of those problems.
Sounds like I need to do that.
No, what's the screen
No,
look like? Is it
just
glowing?
white. Yeah.
Okay, well, it's glowing. That's good. Did you
Yeah.
try
At
the
least I
other
didn't mess
screen?
anything more up. Yeah, I can try. Well,
Oh, you have to close the jumpers on the
yeah,
other.
I have to close
Yeah,
those.
yeah.
I'm also almost out of solder. I'm probably gonna try to order more. Do you just get like off of Amazon? Just like lead-free solder?
No, 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 no. It's very, very
Oh,
specific.
okay.
I did not give you enough solder. That's my fault. Um,
Well, enough solder for one,
oh yeah,
maybe.
maybe. I should have given you a lot more. I will give you a part number. Um,
Okay, thank you.
the alloy determines um, how it's gonna melt. Um,
Oh, yeah.
right? So lead-free solder, there are different alloys, um, and you want the good one.
All right,
Plus
I will.
all of that flux that's in the middle, right? Remember the
Mhm.
solder's a tube. You want to have
Yeah,
a flux that's the right kind. Um, because if you use an acid flux on electronics, the acid will continue to eat things later. Um, and it can eat through your connections. Um, so
how
you
we
don't
ever managed to make anything is insane.
well, remember we were talking about, people banging rocks together and telling stories,
Yeah,
right?
yeah,
You have to bang the rocks together really, really carefully.
yeah.
And if you bang them together a little bit wrong, like
Mhm.
if you're making a stone axe, right, and you're trying to chip the edge off to make it sharp, if you bang it the wrong way, or just that particular rock doesn't fracture well, then you have to start all over again. Um,
Yeah,
right? So every time you make any connection on this, you are doing exactly that.
yeah,
Right? So it takes 1,000 bangings of rocks together, maybe 10,000 bangings of rocks together to build one of these
yeah,
simple things. And each one of them can go
yeah,
wrong. You can think of it as we're stacking little bits of technological progress on top of each other, and we're way out on the real fragile end of it. Um,
yeah,
so yeah.
yeah. Dang.
Well, and it's like anything else. If you put too much salt in your sauce,
Yeah,
it's
yeah,
going to taste really terrible. But if you put not enough salt in the sauce, it's also not going to taste very great, right?
yeah,
Um, or if you cook it too long, it burns, right? And
yeah,
then your sauce is ruined. Um,
yeah,
so, or if you left the onion too long and it's gone a little off and you use it in the sauce anyway, right? It's like all of those things. It's just like everything
yeah,
else.
yeah. It's just so crazy. And it's like every week I like rediscover it. And I'm like, man, how do we do anything?
Yeah, yeah, yeah. That's so
Uh,
this particular profession of electrical engineering um, is you have to be the right kind of person to do it. And the right kind
yeah,
of person is the kind of person who can go, okay, I have to do 50,000 things and each of them have to come out right. And
yeah,
when they don't come out right, I am determined to continue to work with them until they do come out right.
yeah.
Because if you're like, nah, I did 10,000 of these things and it should have worked and it doesn't, and I'm done, right?
I'm definitely not like that. I'm definitely determined to get this one to work. I mean, it's just it's the first one. I'm learning what hiccups to expect and
Yeah, yeah, yeah.
yeah,
So the other thing that you can do is if you really can't figure this out, you can
Hmm.
build another one. And in the
Hmm.
process of building another one, you might find something that, so maybe the other one will work, right?
Yeah,
And then you can compare the two and see, well, this one's working, this one isn't, why? Right? Or you
yeah.
can, or the other one won't work in the same way. And then you go, oh, okay, now I have two of them that aren't working in that particular way. What am I doing wrong? Because I know that Paul and Mike have built a bunch of these that work. Um,
Yeah,
right? So, yeah, it's doable. You can do it,
yeah. Thank
but
you.
it requires a different kind of patience.
Yeah. Here's the thing. I know I can do it too. I
Yeah,
just
yeah,
got to make sure I have the time to do it as well.
yeah, yeah, yeah. And you need more solder.
Yeah,
So let me
yeah.
remember to get you a part number.
Thank you. So much for getting it done before the holidays.
I thought that was a little ambitious, but I mean, you coulda. You have enough detail orientation to how you approach things that it might have worked.
Yeah,
Um, but yeah, it didn't. Um,
yeah.
I told you about the
Oh,
fin control motors, right?
hi. The what?
The fin control motors. But you were about to say something else. I'll remember this.
No, 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 no. No, no, go ahead.
Okay. So Dale used to work for a defense contractor. Um,
Hmm.
and they built a missile and they launched the missile and it went up and it started to spin out of control. And it exploded off the pad and everybody was really upset because it was a big expensive missile. Okay.
Yeah,
Um, so they did the engineering fault analysis and they worked all the way through it and they're like, oh, this set of wires from the guidance system goes down to one of the fin motors that causes the fin to change its position a little bit, right? To steer the motor or to steer the rocket. Um, and they had them wired backwards so that when the guidance system wanted the fin to deflect this way, it actually deflected that way, which made it worse, right? Um,
yeah,
so they went through the whole thing and they said, all right, so fin team, guidance team, right? You all are going to fix this, right? And they said, yeah, we'll fix it. And so 6 months goes by and they go to launch the missile and it goes up and it goes out of control and explodes. They both had fixed it. One team had flipped the polarity on their wires. The other team had
yeah.
flipped the
But
polarity on their
there.
wires, and
But
they
was
had
the exact
exactly
same
the same
thing.
problem.
Yikes.
And that is known as interface control, right? It's the interface
Yeah,
between two different systems. And interface control is really hard and really, really, really important.
yeah,
Okay. And what you're dealing with right now is a small form of interface control. You have a display that's interfacing to your processor, and
yeah,
somebody's not working right between the two. Um,
yeah,
so, um, yeah. And your Stella hasn't exploded yet, so that's good. Um,
yeah. I really was close.
oh yeah?
I mean, when yeah, I bridged power and ground together, and I go
Oh
to
yeah.
plug it in, and just Matt was like, I don't know how you didn't break it, genuinely.
Oh,
Like,
because the modern voltage control uh, components can tolerate being shorted to each other. They're designed
oh,
to do that and to fail gracefully when that happens.
okay,
So they try to make 3 volts, and if they can't
yeah,
make 3 volts, they just give up instead of pushing as hard as they can until they destroy themselves.
that's funny. Okay, that's good then. Well, at least I figured out why.
Yeah, yeah.
But yeah, I genuinely was like, oh my gosh, this is not, this is not gonna work ever again.
Yeah,
But
with
then
with
yeah,
older style components, it would not have worked.
yeah,
It would have fried, and you would have seen like a capacitor explode or a transistor
that's
go off in a puff
that's
of
exactly
smoke. Yeah.
That's exactly what he said. He was like, "Did anything smoke?" And I was like, "No, it just didn't turn on."
Yeah. We used to say that the electronics components, if they let the magic smoke out, that they wouldn't work anymore. Um, so, but modern components don't do that. They fail a little more quietly, or they're built
Yeah.
to not fail that way. Um, the other thing that all of these components are built for is tolerance for electrostatic discharge. So
Mhm.
it's wintertime, the air's really dry. Um, if I don't know, have a cotton shirt on and a fleece sweater and you take it off and you get sparks, right?
Yeah.
The amount of voltage needed to ionize the air is something like 1,000 volts, 10,000 volts, 10,000 volts per centimeter. Okay, so when you get a little millimeter long bolt of lightning when you like pull up the sheets or something like that,
Mhm.
that's 1,000 volts.
Yeah.
Right? It doesn't have a lot of current behind it, but it's 1,000 volts.
Yeah.
Um, and
Dang.
and that can destroy modern electronics. Right? They're looking
Yeah.
for 3 volts. If you put the 1,000 volts on them, that's a big deal.
Yeah.
So they're
So
built
should I
with,
be wearing the wrist thing?
well, so especially in the winter, you should wear the wrist thing.
Okay.
But all of those little boards that we're using are built for amateurs to work with. So they're built
Oh,
with
right. So
that in
the
mind. So they
yeah.
have ESD is the term, electrostatic discharge, ESD protection.
Gotcha. Gotcha. Okay. Good.
Yeah. See how much there is
Dang.
to learn? Every time you look a little bit, it gets more and more
I
and more,
know. All the fractals.
right?
Where is the quick button supposed to actually go? Because it
Where's the
doesn't
what
like
supposed to go?
the quick
Oh,
button.
that. It doesn't.
It doesn't. Okay.
That's for
Because
other things.
what? Wait, then what's wait, now I'm confused. Hold on. Let me go back to the instructions. What the frick does Mike connect it to? No, okay. No, we definitely okay. In the video, Mike definitely connects it to something.
No, he doesn't. There's no place to
Yeah,
connect it.
no, I swear he
When you're
does.
building a
He
Stella 1.2,
well,
it's part
yeah.
of the build of the Q2. It's built into the Q2.
No, it's definitely hold on. Wait, let me share my screen. I feel like I'm going crazy.
Yeah, yeah.
Um
I mean, if he's connecting it to something, that's a bad editing job.
like with a cord, not like soldering it in anywhere. Hang on. Oh, do
Oh,
I have a different button?
that's not a quick button.
It says
That's a
click on
buzzer.
it.
It's a quick
Oh,
buzzer.
so where's my quick buzzer? Let me grab that one. That's funny.
That's the part that makes the beep when you start it up.
I thought
So,
his looked different.
yeah. All right, stop
Oh wait,
sharing so
maybe
I can
hold
see
on.
what you're holding up.
Okay.
I have a little bit of a recollection that I might have not had enough of them or not had any to spare when I put the stuff together for you.
Oh, gotcha.
Um,
Yeah,
and
no,
since it'll
just
run
the
without it, I was like, yeah, no big deal. Except that now we use it all the time because it lets us know when we're pushing our buttons.
yeah.
Yeah, okay.
Okay, well that cleared up that question because I was just
Yeah, yeah.
saying like, I don't think this fits in well.
Yeah,
Like,
yeah.
like and when Mike does it, it like lines up perfectly with the hole, but mine is like all off center and doesn't seem to do what it's supposed to.
Right, right.
Okay, well, that makes me feel better.
There you go. Okay, so solder, a buzzer, a display, and a battery would be get you most of the way there.
Yeah.
Okay,
Thank
good.
you. Yeah. And if you have the pieces, I will gladly take them.
Yeah, sure. No, I'm
Thank
not going to
you.
make you shell out for pieces.
Thanks.
It's one thing
No,
if you want
I
to buy a little
appreciate
bit
that.
of solder to keep going, but this is more
Yeah.
than that. So, um,
Thank you. Yeah, I
yeah,
appreciate
yeah.
that.
All right, I'll send you something.
Alrighty. Thank you. Appreciate it.
And yeah, go through that list. Um, buzz everything out again. Um,
Yeah.
and I say again, not because I'm frustrated with you, but because it's a
No, I
universally
know.
frustrating
Yeah.
condition, right?
Yeah.
Go buzz it out again, and
Yeah.
then, right, come back to it with some fresh eyes and buzz it out again. Um, and then yeah. So you put the rotary encoder on there and that worked, right? The test code worked
Mhm.
for that? Okay.
Yep. It when I pushed it, it said push, and when I twisted it, it had degrees, and when I twisted the other way, they were negative. So
Right.
that was
Good.
great.
Yeah, yeah, yeah.
Yeah.
Um, so that's the first one, and then the display is the next one, right? Okay.
Mhm.
So you already have some proof that you're not incompetent at this,
Yeah.
right?
Yeah.
Right? You built something and it works, and you knew that it works, and then you go on and now that's not working. Right? But so you
Yeah.
have both ways now. You put something together and it
Yeah.
worked. You put something together and it didn't work. Um,
Yeah.
so yeah. Okay. Good.
And hey, I mean the touch screen works.
Oh, and the touchscreen works.
And the touchscreen works, which is crazy. Like seeing the technical end of how touchscreens work and how it's like,
Yeah.
yeah, this is like literally where you're pl like
Yeah, yeah.
this is where you're touching. Crazy.
Yeah, it's wild.
Yeah. But so that works. So
That's good.
maybe yes, maybe it's not the board, but we'll
It's
see.
probably not the board. It's
It's
probably
probably
the
not the board.
wiring.
Yeah,
Um,
I would imagine it's probably the wiring. I'm
and
sure
yeah,
there's something somewhere or yeah. Oh well. It'll be a process, but I'll figure it out.
right.
I'm off Friday, so that's probably when I'll
Oh,
kind of
okay.
figure
Good.
everything out. Yeah.
Yeah, yeah, yeah. Right.
Yeah.
And then, turn around and say, "Hey, Paul, I got here and I don't understand what to do next. Let's have a meeting and we'll
Yeah.
make some time." So,
All right. Great. Thank you.
good. All right.
Good.
Congratulations on finding out about buzzing out. There's
Thank
no there's
you.
no like happy easy way to learn that. So
Yeah.
yeah.
Yeah. If AI could take over anything, that would probably be top of my list.
If what? Oh, if AI could take over
If
what?
AI could take over
Yeah.
anything.
Well, we did build, so when you make a cable to go between two things and you're making that cable by hand, you want to make
Mhm.
sure that all the wires go where they're supposed to and that they don't go where they're not supposed to. And if you have a 55 pin cable, what you do is you take A and you check it against B, and then you check it against C, D,
And
E,
then
F, all the way through to
C.
55
Oh my
pins,
gosh.
right?
Yeah.
And then you've already checked A against B. So then you go to B and you
B,
check it against
C.
everybody except A because you already checked, right?
Yeah.
And then you do that for all 55 pins. And we eventually automated that with some microcontrollers. Um,
That's nice.
yeah,
That's
but
yeah.
not until after 10 years of doing it by hand. Um,
Yeah.
so
Yeah. Yeah. Nope.
yeah,
I'm glad I don't have to do that.
yeah, yeah. But I mean, when you're building spacecraft, that's what it's like.
Yeah.
Right? It's like everything
Yeah.
has to be connected to everything else, and all the interfaces need to be controlled. And
Yeah.
people who are bad at it design it so that cables on one end are not the same as on the other end. So then you have to have a lookup table for that cable and go, oh, so A is supposed to go to Q, um, right? And which end am I looking at? Is it Q goes to A or is it A goes to Q? And is it pins or sockets?
Yeah.
And what's the shell like over here? And all of this kind of stuff. So we try to make all of our cables go pin to pin, um,
Yeah.
and do the complicated stuff someplace else besides the cable. Because there's just too many ways it can go wrong.
Yeah. Yeah. Seems that way.
Yeah, yeah.
Seems that way.
All right. Well,
Alrighty. Well, thank you for
enjoy.
meeting with me.
Oh,
Thank
sure.
you.